In honor of the bridge that fell, I will be Francis Got Key again. I'm not really sure why they named that bridge after the guy who wrote this national anthem. Oop, what did it change for? I don't know if there's two T's in it or not. Francis Got Key. There's probably two T's. We are going to solve exponential equations. Today is the 26th, the day after payday. Of course, for me, it was the day after payday. I didn't know that everybody else said the checks went to the bank early. 1B. All right, so the steps that she lists are the same steps I'm going to use. It's very mechanical. I hope you got your calculator because I learned something the other day when Kayleen showed me how you can literally trace on the graph and find very important points, because it actually, if you get to the y-intercept, it labeled it as y-intercept. That's, to me, awesome. Well, if you're looking for a 0, well, the 0 will also be there, okay? You can trace to the 0 if it had one. Well, since we have equations now, stuff on two sides, you're going to have zeros now, okay? Because you're technically going to look at two different functions that are merged together. I don't know if I can show you on the calculator how it's done, but anyway, by hand, we're going to do by hand today. Use the property of exponents that we've already talked about before. I know I'm going to have to review it, and simplify both sides of the equation. And it says, rewrite the equation so that both sides have the same base. That's the important thing. This is the most important thing. Get the same base. The base is the number that has the exponent or has an exponent. You awake, Maria? You getting this down? Okay. Once you've done that, then you are able to just set the exponents equal to each other and solve it. So let's do a very simple one. We're going to do a couple very simple ones. Yeah. Yes. Now, notice number 1. There's already the same base on each side. Do you see it, guys? Do you see the 2 and the 2? They're the same. There's this rule that says if you have an equation and on each side are like bases, then the exponents have to be equal, which implies the x plus 1 has to be equal to the 9. That is if the bases are the same. Well, that's very simple. Everybody in this room, Elijah, wake up. Everybody in this room can solve this equation. You know I pick up your notes every day now. And if you're in class and you sleep through the notes, there's no makeup. There's no makeup. Because you're not going to get that benefit of sleeping all in the class and then, oh, I'm going to turn it in somehow. No. Minus 1, x must be 8. It's as simple as that. Calculator verified that the solution was x equals to 8. Now, this work is required. Just because our calculator can find the answer, the work is required. I used the calculator that when I typed in y equals to 2 to the x plus 1 minus 2 to the 9, is I used that to check my answer. Try to remember how it looked like. I don't know what it did. Something like that. I don't know if it did. I gotta go back and look. What did it look like? It's not that way because it's a grow. So I gotta grow. So that point right here, that is called a 0. That's how you can check your answer. So I'm all for giving you a method to check your answer, but the work is required. Okay, number 2. Yes. Yes. 843. So this problem, again, has the same base on each side. So because you have an exponential function with the same base, then you know that the two exponents have to be equal. So 4m plus 5 has to be n minus 7. That equation is not as easy as number 1 because I need to get all the n's on one side. So really quickly, I'm going to get rid of the 5, minus 5 both sides. That's 4n equals 2 and n minus 12. Then I have to subtract n on both sides. That gives me 3n equals to a negative 12. Now I divide both sides by 3, n equals a negative 4.
Where'd you get the 3?
4n minus an n. That's a 1n. 4n, I have to minus n from both sides. This is basic algebra equation that we had at the beginning of the year, solving a linear equation. That's all that is, a linear equation from the old days. So everything you've learned in the past is always going to come back and haunt you like a ghost. Everything you learn, whether you like it or not, may come back. So when you say, will I ever use this? Yeah, probably. If not in another math course or later on in a math course, maybe in college when you're doing a business class and you literally have two linear equations that you have to work with in business. And I know computers can do the work for you, but they still make you do everything by hand. Do you think an accountant really, for real, the real job, do you think an accountant really takes this big spreadsheet and adds everything up by hand, subtracts all the bills, adds the interest rate? Do you think they do that all by hand? That's called keeping the books. They don't do it by hand. But in the classrooms, you do. You do them by hand in this college. Then later on in college, you learn how to use the computer. What you need there, Dylan? All right, that was an easy one. Let's do another easy. Oh, this is not as easy. The one thing that's good is all the bases are the same. But you have on the left, you have two bases being multiplied together. And you have to remember the rule. I'm going to write the rule because I know you forgot it. You should write it down. When multiplying like bases, here's what we do. We keep, that's bad. We keep the base and add. When multiplying like bases, that's what this one is, multiplying like bases, you keep the base and add the exponents. Remember that rule from Algebra 1? Properties of exponents? Yeah. Okay, so to keep the base means I keep the 3 and then I add the exponents. So what am I adding up? a k. Let me do another color here. A k plus a k plus 2. All equal to the 3 to the 5k minus 1. That one did not change. So now your job is to add up this k plus a k plus a 2. What is a k plus k? How many k's is that? 2 of them. So you still have the 3. Now you have 2k. I still have an extra 2, so I just go plus 2. Now is equal to 3 to the 5k minus 1. So you did all the hard work now. Now do the new lesson. The new lesson says when you have an equation with the same base on both sides, we're going to realize that this will be equal to this exponent. So you write out 2k plus 2 has to be equal to 5k minus 1. This is just old-fashioned Algebra 1 from ninth grade, or even for some of you, you were advanced, 8th grade. And then maybe some teachers taught it maybe even in 7th grade in some class. I don't know, it happens. So I gotta get all the k's on one side. Where's the negative 2? Say it again. Well, I have the k plus a k is 2 k's. Then I have a plus 2. Then over here I have a 5k minus 1. I don't know where you're... You know, I didn't put no signs yet. I haven't done anything yet. Oh, yes. When I solve for k, yes, you're doing the inverse. That's what she's saying. So I'm going to get rid of the 5k's on the right by subtracting 5k's from both sides. I don't like having that little bar under there. It'll let me erase it. Okay, so it was a 2k. So I'm going to go minus 5k. Cancels here. Let me continue that work over here. What is 2k minus 5k? Right here. What's happening right here? 2k minus 5k. You got a calculator. You can pick it up and type in 2 minus 5. Negative 3k. Thank you, Dylan. Already worth your weight in salt for being here. Negative 3k plus the 2 now is equal to negative 1. It's 8:51. Now what I do to finish solving this? Gotta flip the sign. That's what Kayleen said, to get rid of that plus 2. Minus 2 minus 2. Cancels. Negative 3k is a negative 3. Yes. Very good. She added the 2 negative numbers. Divide both sides by a negative 3. What's k going to be now? Oh, it will be 1. The negatives cancel, right? Whoop, wrong color. K is going to be 1. Nice job, Dylan. And Kayleen, thank you for your help. That got harder because we had more steps to do. Now, granted, I can do the calculator and I can get that answer 1 probably in a minute. It probably took me 3 minutes to do the work. But you have to do the work. If you only put down answers, I don't know where those answers came from. So you'll get a point for the answer, but you won't get the 5 points for all that work. All that work is worth more. Another ugly one. What's different than 3? I have like bases multiplied together on both sides. What do I do with the exponents? Already forgot?
Keep the base and add it.
Keep the base and add the exponents. So I go over back to here. I'm going to keep this base, and I'm going to add the -4. I'm going to add it to the 9. Equals. Keep the base and add the x, or a v, I'm sorry, v plus 4, and add that to 2v minus 11. Is that correct? I'm sort of cheating in a way because I didn't show all the steps yet. I just said add these exponents, add these exponents. So what I'm going to cheat again. I'm not going to add them right now. I'm going to add them, but I'm going to get rid of the base 10. Because what's the rule now? Today's new rule. If you have two bases the same on each side, what's equal? What can I write down that is true? I'll just say it one more time. You guys are going to have to start. I mean, you want me to go through these notes 100 miles an hour just because you're not really there? I'll do it.
Is it what you wrote down?
Huh?
Is it what you wrote down?
It's what I wrote down?
Is that what it is?
No. I want you to tell me that I have to take this exponent, set it equal to all of this exponent. That's what I wanted to hear. They are exponents. That whole thing's this ugly exponent.
And the tens are the base.
The tens go away. That's right. They're the bases. So let me write down what I have. What's a -4 plus 9? I probably can do that in my head. Can you? How much?
14.
No. Use your calculator if you have to. -4 plus 9. 5. So I know 5 must be equal to a v plus 4 plus 2v minus 11. And if I have students in here who are so good that they could have just said a v, let me do a change of color. The v plus 2 v's are how many v's?
2 V's.
Nope.
3 V's.
3. And the plus 4 and the plus or minus 11 gives me how much? 4 minus 11 is how much? -8. Close. -7. So I have some students that could have just done this. 5 equals to a 3v minus 7. I do have students in here who could skip this step here and just write that. I'm okay with that. If you can add them up and write down what those combine to get, I'm okay with this line. But if not, I wrote it all. Now I'll do the work. 5 equals to 1 plus 2, 3v. 4 minus 11 is minus 7. Okay. So you understand what I'm saying? You can skip some steps if you can do the math in your head. Add 7, because I want to get the v by itself. Cancels. 5 plus 7? 12 equals to 3v. Divide both sides by 3. What is v? 4. Thank you for your help. There's a lot of work there. You could probably skip one of those steps if you could do this before you write it down. Those were supposed to be the easiest because on each side you had the same base. Oh my. Look at number 5. These equations do not have a common base. They do not have a common base. So what you want to do, you want to light a candle, say a prayer, and ask yourself, can the bases be made the same? Is there another way of writing a 36?
6. 6 times 6.
You are so good. But can you make me an exponent? 6 to the what?
6. 3.
No, so that'd be 6 times 6 times 6.
2.
6 to the second. You did it. You didn't even need me to tell you. She did too. I know. You guys are good. So that means the rewrite would be this. This is a rewrite. You should do the rewrite. 6 to the 2x minus 10 is equal to 6 squared. Why does that make it easy to do now?
Because it's 6 times 6.
Yeah, I know, but what do I do now? What makes it so better than it was?
Same base.
Same base means what? Exponents are?
Are added.
No. Both sides. The exponent on the left versus,
Equal.
they're equal. So we know that 2x minus 10 has to be equal to 2. Now this is just an 8th grade problem. Add 10, cancel, 2x is 12. Divide by 2, divide by 2. How much is x? 6. 12 divided by 2 is 6. Let's go ahead and see if the calculator can do this answer. Let's see if it finds it. In my calculator, I need you to all pick it up, and you're going to do 6 to the 2x minus 10. You're going to take this 36 and move it over. Minus 36. Because what is, when you have your equation set equal to 0, you can type the equation in your calculator like this. So did you write that down? Because I'm going to forget. You know I'm going to forget when I go back. So let's go see what it does in the calculator. With our calculator, we were able to verify that the graph crossed the axis right here when x is 6. And of course, the y value is 0. So the ordered pair is 6, 0, which means 6 was my answer. Now, I'm not going to show that anymore because today's lesson is not about the calculator. It's about the algebra. But it's nice to know. Okay. Number 6. And I think I'm going to have to go to the next page. So I'm going to pick on one of those. Well, no, 6 is just like number 5. Another name for 8 would have turned that into 2 to the 3rd.
Yes.
And then you would say n minus 7 equals to what?
And
Is that an n? Oh, it's a p, sorry. Remember, I'm blind. P minus 7 is equal to what?
equal to 2/3.
No,
8. 3.
3. The exponents, as long as your bases are the same, are equal to each other. So you can finish that up very easily. You should finish it up. I'm not finishing it. You finish it up. I'll give you a second. I did it. So I know you can also. Look at 7. What do you think the common base needs to be? If there's a 7 base over here, is there a way to make this into a 7 base? How would I make the 7 go upstairs? What power would I give it that would mean the same thing as 1 over 7?
7 over 1.
A what?
7/1.
No, that's not the same as 1 over 7. I need an exponent. Right here. Can't be a 1. Well, 7 to the 1 is 7. How do I make that 7 go downstairs? We had this already. -1. Who said that? You said it by yourself? It is -1. Yeah, that flips it to 1 over 7. Yeah. So then we know that 4x plus 11 must be equal to a what? -1. So I'm going to subtract 11 from both sides. That gives me 4x is a -12. Divide both sides by 4. That gives me x equals to
3.
close.
-3.
Nice. Good job. So I set up number 6 for you, and you have your own answer there. Let me do 8. Yes. Look how powerful you guys are. You're looking at these equations that if you were going to a party on Friday night and you said, hey, everybody, let me show you this problem. Oh, you don't think that would impress them?
No.
Okay. No wonder I didn't have a very good time at parties. Dylan, join us. You come in late, now you sleep, and now you're not going to get credit for the attendance because you're not going to get your notes done. All right, so what's my base that I want to try to conform one side into? What base do you see right now?
2.
A 2. Is there a way that the base of a 2 with an exponent be equal to 32? I've seen it before. I think the answer is yes. To what power?
3.
Okay, 3, let's try it. 2 times 2 is 4, times 2 is 8. Nope, not big enough.
Wait, is it like
Is it a 9? I think that's too big.
16? 5.
5 or 16? Which one do I try? Well, it's less work. After coming in a half hour late, you want to go to the restroom. Next time the answer is no. This time I'll say yes.
So can I go on 3rd?
Probably. So let's try the 5. What's 2 times 2?
4.
Times another 2?
8.
Times another 2? No.
14.
No. 16. Times another 2?
18.
You're adding. It's multiply.
Oh.
2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2, 32. So whoever said the exponents of 5 is the winner today. It's a 5. Gives you 2 to the 2m minus 9. So with that being said, that exponent and that exponent must be what? Equal. So therefore, 5 has to be equal to 2m minus 9. And using your powerful Algebra 1 skills, you go add 9 to both sides to get the m by itself. That gives me, even without a calculator, that's a 14. 14 is 2m. Divide both sides by a 2. M is, drum roll, 7. Thank you. Good job. So something as difficult as this is broken down to something simple that you already know how to do. Elijah, again asleep. Number 9, you choose. Let's do 9 or let's do 10. Which one? 10?
Yeah.
All right, so here I go. Oh, yeah, I see how the problem here is. The base here is a 4, and this base is a 16. Can a 16 turn into a base of a 4, or can a 4 turn into a base of a 16? Which one would be easier? How do you make 16 with a base of 4? Times 3. Oh, that's the exponent of a what? 2. So watch this. Keep the 4. Keep the y plus 2. Now the 16 turns into a 4 squared, right? But it already had an exponent up here of a y plus 3. You keep it. Another rule that you have to remember.
Y minus 3 is
Oh, thank you. You are fabulous, let me tell you. There's another rule. We had a rule over here. That was a rule from the past. Here's another rule. This rule says, I'm at the wrong place. It's down here. That rule says a power, which means exponent, to a power, a exponent that has an exponent, we multiply the powers. Remember that rule? That looked like this, guys. 4 squared all to the 7th is 4 to the 14th, because you multiply. So,
Can you zoom out?
oh, I was just doing an extra problem just for fun. But this is what the rule was. But if you wanted to see that, fine. So go back to my problem. Here is my power to another power. What do I do with those two exponents? Huh? What do I do with the 2 and the y minus 3?
2 times 1 and 2 equals 3. Negative 3.
Exactly. She's already saying, hey, I already know I'm going to distribute that. Nice. I'm not going to write it distributed yet. I'm going to just write it out. Y plus 2 on this side will be equal to a 2 times a y minus 3 on this side. And Destiny already said that I have to distribute this. That shows she has a good math background. So y plus 2 is, she already told me the answer. That's why I'm writing it. She said 2 times y, 2y. 2 times a negative 3 is a negative 6. So I got to get all the y's on one side. Doesn't matter which ones you move. I'm just old-fashioned. I'm going to move the right side to the left side by doing the opposite sign. That's what Kayleen said earlier. You do the opposite signs. 2 y's cancel out the negative 2 y's. So now I have a 1y minus 2y. How many y's will that give me? I didn't hear anything. No.
What?
Can't be a negative 2y.
You said negative 3y.
No, one of them's negative. Negative 1y, yeah. 1 minus 2, that's what this is. 1 minus 2 is a negative 1. I'm just going to write negative y. You're going to go now, Maria? Let's get the answer first and then go, okay? 9:15, Rosario. Negative y plus 2 now is a negative 6. Subtract 2 from both sides to get the y by itself. That gives me a negative y equals, they're both negative, so you got to add them and keep the negative. Negative what?
8.
Then I got to divide both sides by that negative to get rid of this negative here. So reality is y equals, divide by a negative 1, what do you get? 8. There's your answer.
Just.
That was a pretty tough problem. And if you're saying to me, sir, that wasn't hard. Okay, then let's do some more then. What's on the second page? All right. Now, once they start getting really super hard, I'm going to be honest with you. I'm probably not going to test you on the hardest ones, okay? So I'm just going to do probably, based on our time, we actually got a lot of time.
Sir, we should do.
Half of these.
What?
We'll do half of these.
Can we choose? Which one?
All right, you choose.
Okay, you should do first 11.
Let's do 11 then.
15.
Okay, 11.
No, sir. 13.
And what?
13.
13. What else? Anybody else going to beat her? She's going to name them all. If you guys want input, Dylan, you want to pick a problem, you better pick it while you're awake. Give me 2 more. Which one? 12.
Is it 18?
You want me to do 12? That'll be another easy one. Another one? Better pick one of the harder ones. 20. She said 20. So we'll see if we can get, well, if we have, okay.
And 19.
You don't have to do them all. We might have time to do them all, but for now, let's get these that we already picked. That one's not hard. One of these numbers can have the base of a 125 or a base of 25. The question is, can 25 have an exponent that would give me a 125? Well, that's 5 but I need a base of 25. You have to ask yourself, well, no, but we want to keep the 25, not turn it to a 5. You could do that, though. Actually, she's onto something. You could turn these both into bases of 5s. She's actually right. She could call this 5 squared. But what's another name for 125? How do you make 125? Try 5 times 5 times 5 and see if that works. If that doesn't work, do 5 times 5 times 5 times 5. 4 of them.
Oh, 3 times.
3 times?
5 times 3.
No, 5, no, not 5 times 3.
5 3 times.
That's, yes, 5 times 5 times another 5. So change that to 5 to the 3. And it already had a y exponent. It already had a y exponent. Actually, Kayleen, we couldn't have done it except for the way you did it. Now that I'm looking at it,
So you're saying that, like, no?
I'm saying that you saved the day.
Oh, I think.
Because what I was trying to do, I was trying to keep the base 25.
I saved the day.
Unfortunately, 125 squared is not going to give you 125. 25 squared is, I think, is 625. So you did the best thing by turning them both with bases of 5. So what is 5 becomes, multiply these? What's 3 times y? 3y equals to 5 squared. Oh, now it's easy, Kayleen. Thanks to Kayleen, we know that 2y has to be equal to 2. So what must y be?
Did you say 2y or 3y? 3y.
Oh, it's 3y, sorry. 3y equals to 2. See, look at that. You guys are good. So what's y going to be? Divide both sides by 3.
1.
Come on. You got a calculator there. You can literally type in 3 divided by 3 and 2 divided by 3. But I'm just going to leave.
Give me a fraction. It gives you a fraction.
Then I'm going to leave it as 2 over 3 then.
Okay.
What's wrong with that answer?
No.
Just because it's the F word doesn't mean it's bad.
F word.
Fraction. The most famous F word in the world. What, the fraction? You know, I hear that all the time. All right, you wanted 12. I want somebody else to use Kayleen's idea.
Hey, sir, you know how to turn it into a fraction? I do, too.
From the calculator?
Yeah.
Nobody else knows. I already asked everybody. They don't know.
What? It's easy. Yeah, 0, 6, 6, 6, 6, 7, 7.
Let's use Kayleen's trick. Can the 16 and the 8 become a base that's the same base and give you those answers? What base could you use? A 4. 4 squared is 16, but 4 squared won't give you an 8. And 4 to the 3 won't give you an 8. And 4 to the 1 won't give you 8. It's got to be smaller than 4. 2. How would 2 work? 2 to the what is 16? 2 to the 8? No. 2 to the 4? How'd you do that so fast? 2, 4, 8. Stop adding. Multiply. 8. And 8 times 2 is?
16.
Very good. So she's right. 2 to the 4. Wrong color. 2 to the 4 is 16. So all of that has to keep the exponent of a 3x. Equals to? How do I create the 8? 2 to what power? 2 to the 3. Man, it's this side of the room is this really on fire. The 8 becomes 2 to the 3, but I still have the exponent x plus 2, right? Good job. What does it mean, power to a power? What do you do with the exponents? Do we add them? Multiply them. Do I keep the base 2? Yes. And what is 4 times 3x? 12 what? X. Equals to? Keep the base 2. These two powers have to be multiplied together. That's a 3 times the x plus 2. Now that we have the same bases, what's true?
They both have both bases.
They have the same base, so what does it mean? What's it mean? The 12x is equal to what?
So why didn't you multiply the 3 by the x and the 2?
I'm going to right now. I'm just waiting for you to tell me what it is. 3x plus 6. See, she already knew we had to do that. Get all the x's on one side. I'm old-fashioned. I'm going to go subtract 3x. That's right, 3x. Cancel. 12 minus 3? 9x is? Equals to 6. Finish it up. Divide both. I'm going to do it. 9x equals to 6. Divide both sides by 9. X is? Another fraction. Is it a 9? Yeah, it was. Where did I get the 9 from? Oh, yeah. It was 12. It was 12 minus 3. Right here. Gives me a 9. So reduce 6 over 9. 2/3. Oh, same answer we just had, isn't it? It's not fair. Same answer twice. When I get the same answer twice in a row, I think I'm wrong. That's true. Well, that's the variable. You picked 13. I don't know if we should do 13. We already did 4s and 8s. Yeah, we already did, well, we did 8s. Obviously, we can do the 4 as a 2. I'll just set it up, then we'll move on. 2 squared raised to the 3x has to be 2 to the 3rd raised to the x minus 1. So I think you could finish that on your own. Very simple. Which one did you say?
18.
18. Oh, you were begging for 18 a minute ago. You sure?
I know better, but I'm begging for 18.
Okay. Let me think about this for a minute. Obviously, the base here is a 9 and the base here is 9. I wonder if there's a way to make a base 9 on this side. I just saw it.
9 times 9, 81.
What?
9 times 9, 81.
Okay, so, but I can't put 9 squared because it's in the denominator. So instead of a squared, what do I put? How did we do it before with the 1/7? We put a -2.
Oh, that's right.
9 to the -2. Check it on your calculator. Will be a 1/81.
1 and 2. I mean, a 1 and 1. Negative 1 and 1.
Okay, so back to the left. If we're going to keep the base 9, what do I do with these two exponents? Do you remember what we do with these two exponents?
Ow.
Do I multiply them or do I add them? Add. I don't know who just said that. Somebody over there. So 2x plus 4 added to 2x's must be equal to just the -2. 9 to the -2, sorry. What is 2x's plus 2x's?
4.
4 what?
X.
Then I still have the 4. So now that I know I have the both 9s, all of this has to be equal to this. So 4x's plus 4 is a -2. All I got to do is get rid of my 4, minus 4, minus 4. 4x's is a, pick up your calculator if you don't know what -2 minus 4 is. It's got to be negative. -6. Divide both sides by? Okay, Kayleen. How did you pick 3 problems that have... Oh, no, it's not the same answer. I thought it was the same answer as before. What is x going to be? X is another fraction. -6 over 4. What does that reduce to?
-6 over 4 equals to -3. -3, 2.
-3 over 2.
Yeah.
Okay, the last one that was picked, besides that one that we didn't finish up here, the last one, usually the last one on the page is probably the hardest of all of them. And I think it is. So I see 4s and a 4. Is there a way to make 1 over 16 to have a base of a 4? 4 to the what is 16? Guys, I'm doing 1 over 16. Can I turn it to a 4 with some power? 4 to the what is 16?
Oh, is it like, is it, no, I don't know, 2?
4 to the 2. But because it's in the denominator, do I use a 2?
-2.
-2.
Like the last problem.
Like the last problem. Yes. Can I reach the door? Oh, nope. Oh, I didn't reach it. I could have reached it if I had just pulled this up. Oh, well. I know. I go through a lot of them, though. And they're not cheap. So, I can turn these all to a base 4. I already have 4 to the 2x times, you told me this will be 4 to the -2 equals to 4 to the 6x plus 18. So it was hard. You had already had a hard step there. But this is our third time that we did this. It's the third time that we did this. You looking for the time or the pass?
The pass.
Maybe somebody's still gone. Who just came in from the restroom?
I just came in, but I didn't take pass. I
The-
didn't know where it was.
Is it hanging up?
No.
Let's take a look. So we got all base 4s. What's the rule on the left-hand side here with these two? How do I keep the base? What do I do with the powers? Add them. Keep the base, add the 2x, and add it to a -2, which means add a -2 or just -2. And then the right side just has the base of a 6x minus the 18. Plus 18, sorry. What's true now? Can I get rid of the base 4s? Yes, because once I have the same base on each side, all of these is equal to all of these, right? So I don't know where I want to put it to have enough room. That means 2x minus 2 has to be equal to 6x plus 8. And I'm still old-fashioned, so I'm just going to get rid of these 6x's. Minus 6x, minus 6x. Those are gone. What's 2 minus 6? Nope, it's not 4. Negative 4x's minus 2 equals to 8. Get rid of the minus 2 plus 2 plus 2. Negative 4x equals 2. What is 8?
Isn't it supposed to be
18? It was 18. Yeah, I see it. 18, 18. Thank you for saving our bacon. So it's going to be 18. Okay. Negative 4x equals to 18 plus 2. 20. Divide both sides by a -4. X is, drum roll, not 5. -5. Da, da, da. So we did the hardest problem on the page with very little effort. I think we did 1, 2, 3, 4. Well, we're almost at the end. I can pass out to you what you have to get done. So I'm going to call this a day. There is an assignment.
Can you do 15?
Did you already look at it? Does it look ugly?
Somewhat.
Sure does look ugly. I'm going to do the Kayleen's way. I'm going to try to find a smaller number as a base that can be used for the 8 and the 32. And I think we already did that earlier. What base could you use to become an 8? I only can think of one base. What number?
8 times 8 to the 4.
8 to the 4?
Yeah. 8 times
No, but
8 times 8 4 times.
but 8 times 8 times 8 times 8 is a super. No, you're adding again.
No, look.
You're adding.
It's multiplying.
No, 8 to the 8. You did 8 times 4.
Yes, I did.
That's the same thing as adding. I want 8 to the. You said 8 to the 4th.
8 times 4 is 32.
How's that going to help me though?
He wants the exponent.
I want one number raised to some power that is 8 that I could still use for the 32. We've done this before. Try some numbers. 3 times 3. 3 times 3 times 3 times 3. Try 2 times 2 times 2. Try 2 times 2 times 2 times 2 times 2.
Wait, but how is 3 going to go into 8?
It doesn't. I just said try it. Try the 2s then. Try the 2s. Try the 2s. 2 to what is 8?
Okay, 2 to 3 is 8.
2 to the 3 is 8. So this 8 can be written as 2 to the 3. And then this has to be raised to the 2a minus 1. And the other one is what? See, 2 to the 5. All of that is raised to the 2a plus 1. So don't forget, guys, that there's actually a parenthesis here. And remember, Destiny was showing us that we have to distribute this. So let me just write this out. This is going to be a 3 times the 2a minus 2a minus 1 has to be equal to a 5 times the 2a plus 1. And then when you distribute this, both sides, this gives me a 6a minus 3. This side gives me a 10a plus 5. 10a plus 5. Okay, do you understand this?
Yes.
You see what we did? Remember the power to a power? Power to a power?
Is that 10? 10?
Yes, 10a. 5 times 2 is 10a. So then I'm going to subtract 10a from both sides.
Well, the 9 was a 9. I was like
Yeah.
29.
Oh, yeah, good. Oh, yeah, that's what you're saying. 6 minus 10 is a negative 4a minus 3 is 5 because that goes away. Add 3 both sides to get rid of this minus 3. That turns into a negative 4a.
Hold on, sir. You're going too fast.
I know.
You're going speedy one side. It's suspected.
Arriba, arriba. Ándale, ándale.
I don't know what that was.
That was my favorite cartoon growing up. And in Michigan, that was actually the first Mexican I ever saw.
Have you seen Pocoyo?
Let's just continue.
What is he?
Pocoyo? Have you seen Pocoyo?
Yeah.
No, I haven't seen that one.
You should see it. It's very
Continue
funny.
with the equations then.
Oh, okay. I like talking about cartoons, though. I still watch cartoons.
Yeah. Pocoyo?
Pocoyo. What creature was he?
No, he was just like a little guy with a blue.
A little monito.
Anyways, continue.
All right, anyways, negative 4a is, I'll have to go look it up. Negative 4a is how much? How much?
Negative 4, 8.
Yeah, negative 4a, because 6 minus 10 was a negative 4a. The negative 3 is canceled, so I'm going to add 3, add 3.
It's just going to be negative 4, 8, no?
Negative 4a is what? What's on the right side?
Oh, 8.
8. Nice. Divide by negative 4. Divide by negative 4. A is how much?
Give me a minute.
Negative 2. All right. No, I don't do more. That was enough. That's 1, 2, 3, 4, 5.5 problems. I'm going to give you this at the beginning of it. I'm going to give you the homework. Man, what, do you want to out? And you only have to do, you get to pick, well, there's, we go back. 20 altogether, right? 18 altogether. You can pick 9. Any 9 you want to do. Any 9 you want to do. Let me give it to you.